Hello, I'm Cheryl. In this problem, we're going to be using Lagrange multipliers to help us find the minimum value of my function f of x, y, z equals x squared plus y squared plus z squared, where I know that x, y, and z are all positive, and it follows the constraint that x plus y plus z minus 9 equals 0. So I'm going to begin by turning this constraint into a function of x, y, and z. So I'll write g of x, y, z is equal to x plus y plus z minus 9. Now, to use the method of Lagrange multipliers, I'm going to simultaneously solve the equations that the gradient of f of x, y, z equals lambda by Lagrange multiplier times the gradient of g of x, y, and z, and g of x, y, z equals a constant. So for this particular problem, my gradient of f is going to be 2x times vector I plus 2y times vector j plus 2z times vector k. I have my Lagrange multiplier, and I'll multiply that by the gradient of g, which is going to be I plus j plus k. And of course I have my function g, which is g of x, y, z equals, in this case, it's going to be 0. So my two equations become 2x times vector I, 2y times vector j, 2z times vector k equals lambda I plus lambda j plus lambda k. And I have x plus y plus z minus 9 equals 0. Now, when I look at this first piece, I know I have two vector functions that are the same, and so that means that their components have to be equal. So the I components have to be the same. So that tells me that 2x equals lambda. The j components also have to be equal. So 2y also has to equal lambda. And the k components have to be the same. So that means that 2z also has to equal lambda. And I also know that x plus y plus z minus 9 must equal 0. So what I've done is I've created a system of 4 equations with 4 unknowns. Now, if I look at these first 3, I can solve each of them, one for x, the second one for y, and the third for z. So I know that x is lambda over 2. I know that y is lambda over 2. And I know that z is lambda divided by 2. I can take these and plug them into my fourth equation. So what I have is lambda over 2 plus lambda over 2 plus lambda over 2 minus 9 equals 0. That's going to give me 3/2 lambda equals 9, or lambda equals 9 times 2/3, which is going to be 6. All right, well, I want to know what x, y, and z are. So I can plug them back into my equations. So that's telling me then that x, which is lambda over 2, I now know is 6 over 2, which is 3. Y, which is lambda over 2, is 6 over 2, which is 3. And in a similar way, z is going to be lambda over 2, or 6 over 2, which equals 3. So if I look at my function with its constraint, I know that there's not going to be a maximum value. So I must have a minimum when x is 3, y is 3, and z is 3. But in this problem, they actually asked me to find that minimum value. So what I need to do finally is to plug all of my values into my original function. So f of 3, 3, 3 is going to be 3 squared plus 3 squared plus 3 squared, or 9 plus 9 plus 9, which is 27. So 27 is the minimum value that my function takes on with the given constraint. I hope that was helpful. Thanks.